This is a recording from a Sunday meeting of the BC Humanist Association in Vancouver. The opinions expressed in this podcast do not necessarily reflect those of the BCHA or its board of directors. To learn more about humanism and to support our work, visit bchumanist.ca, and make sure to follow us on Facebook, Twitter, and Instagram, and be sure to subscribe to the BC Humanist podcast.
Thanks, Ian, and thanks for having me, everybody. I'm excited to talk to you today about one of my favorite subjects. That's been one of my favorite subjects since I was, before I could walk, just about. Someone beforehand was asking me how I became interested in sharks. I feel like most little kids go through... Down? How do we do that? My camp counselor voice is overpowering your PA system, sorry. Closer? Okay.
How's that?
Testing. Better?
Better.
Awesome.
Cool.
Someone beforehand was asking me how I became interested in sharks, and I said, I don't really know, but I feel like most kids go through a shark thing or a dinosaur thing. I actually had both of those and had to choose and stuck with it. But I'm going to talk to you today about why sharks are important and why a lot of people don't really understand, or a lot of people misunderstand sharks. And one thing that's been fascinating to me moving to Canada from the U.S. is a lot of my colleagues here, scientists, environmentalists, people that are well informed about the state of the world, were not aware that not only does Canada have one of the largest shark fisheries in the world, at top 20 in the world by landings and by exports, but also that Canada has a lot of species of sharks. A lot of people just seem to think of sharks as a tropical group of animals, but you have a lot of species of sharks right off the shores here. And I'm happy to answer any questions about this afterwards, and I can also stick around after the meeting. I currently have no plans for lunch, so if people have questions about sharks that they're dying to ask, I'm happy to answer them after. So I want to start at the start here with what is a shark. A lot of people are confused about this. I get a lot of questions about this. So first and foremost, a shark is a fish. They're different from something like a salmon, or a tuna, or other groups of fish like that. Those types of fish are what are called bony fish, class Osteichthyes. Their skeletons are made of bone, just like ours. But sharks, skates, rays, and chimeras have skeletons that are made of cartilage. So we have both bone and cartilage. If I could get everyone to hold out your left arm, find a point about halfway between your wrist and your elbow, and try to bend it there. Don't try too hard. So you should notice that it doesn't bend. If it does bend, then we need to call emergency services right away. But you should notice that it doesn't bend. Now try that with your ears. Try that wrinkling your nose. That's cartilage. Sharks' entire bodies are made out of that. It's lighter. It's more flexible. It heals faster. Some sharks are, in fact, so flexible that if you grab them by the tail, they can bite your hand while you're holding on to their tail, which is one of many reasons why you should not grab wild animals by the tail. There were sharks swimming in the oceans 100 million years before there were dinosaurs on land. There are, this weird-looking guy up here is Stephacanthus, a long-extinct species, but it's one of the first, earliest things that we recognize in the fossil record as this is a shark. And you'll notice that though it has some weird features like this goofy plate on the top of its head that we don't really know what that's about, it's clearly recognizable that that's a shark, and that was swimming in the oceans 440 million years ago. Unlike other types of fish like a salmon or a tuna, they don't have a swim bladder. They have to keep swimming. Many species of sharks have to keep swimming constantly in order to breathe, but all sharks need to keep swimming constantly or else they sink. And many of them are cold-blooded, but some of the species that we have around here in cold Canadian waters can actually have warm-blooded parts of their body, like around the eye or the brain, they can keep warmer than the surrounding water temperature. Makos can do that. Great white sharks can do that. So these animals are pretty diverse in their adaptations. They have the same 5 senses that you and I do, plus a couple extras that I'll get to in a second. But they have, for each of these senses, it's as powerful or more powerful than it is in humans. Their sense of sight is not often discussed. People think when you think of shark senses, you think of their ability to smell a drop of blood a mile away or whatever, which is not really true, but I'll get to that in a second. They can see better than we can in clear water. They can see better than we can in murky water. They can see better than we can in low light. Some species of sharks can see a little bit into the ultraviolet range, and some coral reef fish have markings that are only visible in the ultraviolet range. We've only recently started to discover this with ultraviolet film. If you take a picture of a coral reef fish, it looks totally different on ultraviolet film for some species. Sharks can hear really well, particularly lower frequency noises, such as those given off by a thrashing animal or an explosion of a naval vessel. This was often an issue during World War II naval battles. It attracts sharks from pretty far away. And the U.S. Navy gave out a series of training seminars to their sailors and pilots saying, if you see a shark, what you want to do is splash around to scare it away. What you're really saying when you do that is, hey, there's a wounded fish over here. Come check it out. Up to a quarter of a shark's brain is devoted to the sense of smell. Their sensitive smells are legendary. They can detect incredibly low concentrations. They can tell the difference between a big fish and a small fish, or one fish and several fish, or a healthy fish or a sick fish by smell. But this idea that sharks can smell, how many of you have heard the saying or the phrase, sharks can smell a drop of blood a mile away at some point? That's not how smell works. You cannot detect something at a distance. When you are smelling something, particles of that something are interacting with chemosensors in your nose. So think about that the next time you smell something gross. But sharks can detect incredibly low concentrations of blood, and it's something like 1 part per 800,000. So it would be about, the Discovery Channel Shark Week says they can smell a drop of blood in an Olympic-sized swimming pool. It's not quite that sensitive, but they could smell like a solo cup of blood in an Olympic-sized swimming pool, which is pretty darn impressive and a lot more powerful than ours. Sharks do have a sense of taste, but it's a little different than ours. They don't have a mobile tongue like we do. They have taste buds on their snout, which explains a particularly distressing shark behavior, if you've ever experienced it, called bumping, which is exactly what it sounds like. A shark bumps into you, that's tasting. If a shark does that more than once, it's an excellent time to get out of the water. And sharks do also have a sense of touch, and that works pretty similarly to ours. But they also have extra senses that we don't have. They have what's called an ampullae of Lorenzini, which are these dots on the snout. That's an electrically sensitive jelly in canals throughout their snout, and they use that to detect bioelectric fields given off by all living things. So if a prey species is hiding under the sand and they can't see it or hear it or smell it, they can still know it's there by sweeping their nose over the sand, that's why hammerheads have that goofy shape. It works kind of like a metal detector. They also have what's called a lateral line, which is this horizontal line on the side of the shark. Lots of bony fish have that too, but that detects vibrations in the water. It's a really cool system. And this ampullae of Lorenzini, the electromagnetic sensitivity, sharks also use this for long-distance migrations. They can tell basically where they are by detecting changes in the Earth's magnetic field. And sharks go on crazy long migrations. The tiger sharks that my PhD lab at University of Miami tagged in the Bahamas swim up to Newfoundland every year, that's a pretty far swim. The record, I believe, is, or it was at one point the record, I think it still is, a satellite telemetry tagged great white shark swam from the west coast of South Africa to Australia, which is there a map somewhere in here? It's really far. Look it up later. Trust me, it's far. And they also have what's called a pineal gland, that most vertebrates have some degree of this, but they're extremely good at telling what time of year it is based on changes in light levels. Sharks have, so people ask me all the time, how smart are sharks? And sharks are not going to write a symphony or a play anytime soon, but they're a lot smarter than people think they are. And they have some fairly advanced social behaviors not seen in other fish. There are some cases of parental care, though in some cases that consists only of an elevated level of I'm full, I'm not going to eat hormone around birthing time, so the mother does not eat the babies. But in some cases, there is actual parental care. Some species of sharks have pretty complex social hierarchies, and some even have social learning. which are things not normally associated with primitive, stupid, whatever wrong term you want to use to describe them, animals. So they're pretty amazing in some of their behaviors. And again, they have these multi-thousand kilometer migrations every year where they come back to the exact place where they started. We recently found out that lemon sharks, which is what these are in the picture behind me, will return to the exact same place where they were born to give birth 18, 20 years later, much like salmon around here are well known for doing that. But really not a lot of animals do that. Since it's Father's Day, let's talk a little bit about where baby sharks come from. There's a lot of different, sharks have an incredibly diverse series of reproductive strategies, more so than most vertebrate groups. Some lay eggs, some give live birth, some have a weird mix of this called ovoviviparity, where the baby hatches in an egg, but that hatches inside the mother and then live birth happens. But it's not in an ova, it's in a true egg. Sharks do not spawn like animals like salmon or tuna do. They have external genitalia and internal fertilization. You would recognize what you're looking at if you saw sharks mating. And if you're curious, on my blog, Southern Fried Science, I have a post about this that I share every Valentine's Day called 50 Shades of Gray Reef Shark that has some videos and diagrams of what shark mating looks like. But sharks also have some crazy, weird behaviors associated with this. One is called multiple paternity, which is if a female shark mates with multiple males, she will give birth to a litter of half siblings at the same time. So these babies have the same mother, but different fathers, even though they're born at the same time. And there's some evidence that the female can choose which sperm gets to fertilize. So if she mates with 10 males, she'll choose the 4 or 5 or whatever of her choice that will result in offspring. That's still somewhat debated, but I think there's some pretty strong evidence of it. Sharks can also store sperm after a mating event until they're ready to give birth. For right now, the record is 4 years. They also are capable of parthenogenesis, which is self-cloning. This was discovered in an aquarium in Omaha, Nebraska. I don't know how good your guys' U.S. geography is, but that's really friggin' far from the ocean. And they had 4 female bonnethead sharks, and it had 4 female bonnethead sharks for years. And one day, the zoo staff comes into the aquarium, and they notice that there's a bunch of baby sharks swimming around. And they weren't sure what had happened. If this was in Florida, I would assume that a fisherman just caught him and dumped him in. But this is pretty friggin' far from the ocean. And they did genetic tests and figured out that all the babies were exact genetic duplicates of one of the mothers. So this has since been found in a few other species and has been seen in the wild with sawfish. So if there's no male around, they're capable of self-cloning to reproduce. Sharks have what's called a K-selected life history, which means that they do not reproduce as quickly or as often as something like a salmon or a tuna. It takes sandbar sharks, which are my favorite shark species, my master study animal. They reach reproductive maturity later in life than humans do. It takes them 14, 15, 16 years to be reproductively mature, at which point they have 6 to 10 babies every 2 or 3 years. Compare that with a mahi-mahi, a dolphin fish, that is reproductively mature in less than a year and can spawn hundreds of thousands of eggs a year. You can see why sharks can be extremely vulnerable to overfishing. Their populations just can't recover as quickly. There are more than 500 species of sharks and more than 1,000 species of skates and rays. People have heard of hammerheads, people have heard of great whites, sometimes tiger sharks and bulls, maybe a few other species. But there's more than 500 species, and there's a new species of shark, skate, ray, or chimera discovered approximately every 2 weeks on average. So people ask me all the time, is there a lot left to do in shark research? There is. There's a lot left to do. I am not going to be bored anytime soon, which is nice. These animals have an enormous diversity of sizes and shapes and behaviors. Some live under Arctic ice. Some live in coral reefs. Some can swim hundreds of kilometers up rivers. Some are striped. Some are spotted. The goblin shark, can be bubblegum pink in color. The biggest shark is the whale shark, seen on the far right side here. That can be the size of a school bus. The smallest shark, the dwarf lantern shark, is about that big. Then they're called lantern sharks because they glow in the dark. So there's an enormous variety of behaviors here. And my coolest go-to shark facts have to do with a species found mostly in Canadian waters, the Greenland shark. That was recently discovered last year that these are actually the longest-lived vertebrates. They can live up to 400 years. So Canada's celebrating its 150th birthday this year. If a Greenland shark was born the day that Canada was founded, it would not yet be reproductively mature. It would still be reproductively a preteen. And these animals get 5-6 meters long, and they eat polar bears and reindeer. So this is a really cool, I could talk about Greenland sharks all day. I hope to get to see one during my 2 years in Canada, but I have to go pretty far north, and I've heard it's cold there, so we'll see. I'm coming from Miami, so this is cold for me now.
Wait till the winter.
Yo, that's what everyone keeps saying. So when most people think about sharks, what they think about is sharks biting people. This is less of an issue in Canada than it is in Florida, but it still makes the news here. I've seen it a few times here in my few weeks. And sharks biting people is something that just absolutely terrifies people. And this is a now infamous Time magazine cover. This was the last one, the last Time magazine cover before the September 11th, 2011 terrorist attacks in New York and DC. At the time, 3 sharks biting people over the course of 4 months was considered major front page news. This is really just not something that you need to worry about. And it seems like since many Canadians didn't even realize there were sharks in your waters, this might be a point I have to hit less in my outreach here than in general. But I want to go through some of this because I think it's important. And don't worry about all the big numbers in this, but this comes from the International Shark Attack File at the University of Florida. In an average year, these statistics are all United States specific. I'm sorry, I'm a new Canadian, but that you can still get the sense of the general trend. In an average year, about 650,000 Americans die from a heart attack, which gives me a 1 in 5 chance of dying from a heart attack in my lifetime. About 500,000 Americans die from cancer, which gives me about a 1 in 7 chance of dying from cancer in my lifetime. And about 50,000 Americans die in car accidents in a given year, which gives me about a 1 in 80 chance of dying from in a car accident in my lifetime. Less than 1 on average is killed by a shark. You are literally 1 million times more likely to die from a heart attack than a shark attack. So quick show of hands, and feel free to not participate in this, no pressure. How many of you know someone who's died from a heart attack? I know I do. How many of you know someone who's died from cancer? I know I do. How many of you know someone who's died in a car accident? I know I do. How many of you know someone who's been killed by a shark? I've asked that question of thousands of people all over the world. I've never had anybody raise their hand. But this gets disproportionate media coverage, and it scares people, and that affects people's willingness to protect and conserve sharks. So hopefully at this point I've convinced you that sharks are neat and sharks are not something you need to worry about. I want to move on now to why sharks matter, why sharks are important. And why sharks matter is my social media handle on everything. It's also my Gmail address if you have follow-up questions. But predators are always important. They help weed out the sick, the weak, the dying. When you hear about survival of the fittest, predators are a big reason why the not fit don't survive. So they're really important in terms of keeping prey populations in check. There's a lot of technical terms like top-down control and things like that we could get into, but I'm happy to talk about it more later if you're curious. But in the meantime, just predators eat the sick and the weak and the dying, and that helps keep prey populations in control. It's a basic point here. And apex predators, those at the absolute top of their particular food web, are particularly important. Not all sharks are apex predators. An orca whale will eat an orca whale can take on and beat the biggest sharks in the ocean. But many sharks are apex predators, and all sharks are predators. There are no vegetarian sharks. This is something that there's one scientist in Florida who argues this point, that they found seagrass in the stomach of bonnethead sharks, but bonnethead sharks eat crabs. Crabs live on seagrass. This is the equivalent of when I forget to pick off a piece of lettuce from a sandwich. That lettuce gets in my stomach. I'm still not a vegetarian. So all sharks are predators. So I want to move. There's an ecological concept called a trophic cascade that sharks have been proposed to be involved in. I want to go through a simple example of that for you. This is a coral reef. This was an easier example to give for another one that's perhaps an easier example to give in South Florida. But how many of you have ever seen a coral reef up close? Show of hands. A bunch of you have. If not, the aquarium has a pretty good South Pacific coral reef exhibit here. But coral reefs are really important habitats for thousands of unique species of plants and animals, some of which can live nowhere else. Algae is one of many threats facing coral reefs. When algae grows, it blocks out the sun, which prevents the zooxanthellae organisms in coral from growing. So coral are plants and animal living together, and they photosynthesize like plants. When algae grows on top of a coral, it blocks out the sun. They can't photosynthesize. The coral dies. Parrotfish eat that algae, and they keep the algae numbers under control so that the coral can get sun and create food. Groupers eat parrotfish, and sharks eat groupers. So in a healthy system, you have it looking something like this. But if you get rid of sharks, which is happening, we'll get to that in a little bit, we're getting rid of sharks at an alarming rate, you have more grouper. When you have more grouper eating the parrotfish, you have fewer parrotfish. And when you have fewer parrotfish eating the coral reefs go from these beautiful habitats to these algae-covered rocks. And that's not the only threat facing coral reefs, but it's a major one. Sharks are also really important economically. This is a picture of my PhD lab swimming in the Bahamas with tiger sharks. I'm not in that picture, though. I have been to that site, but after the university changed their rules that prohibited me from getting to go diving with them. But I've been fishing for them, and I saw them, and it's awesome. But these animals are really important economically for reasons including idiots like my PhD lab mates here that would prefer to, instead of just going to the beach, we want to go scuba diving with big sharks. And there are a few places in the world that have healthy shark populations that protect them. So we go there. And when we're there, we pay the scuba companies, we pay the hotel, we pay the local restaurants. Most scuba divers I know patronize the local bar economy pretty handily. I always buy a T-shirt when I go. So it's an ecotourism is a major source of the importance of sharks, particularly in the Bahamas is sort of the classic case study of this. Other than that, sharks keep these prey populations in check. Many of these prey populations are very important to fisheries and to global food security and to employment type issues. But sharks are, in fact, in trouble. One threat that sharks are facing is bycatch. How many of you have heard this term before in terms of fisheries? A lot of you have. Excellent. For those of you who haven't, that's when you're fishing and you're trying to catch one thing and you accidentally catch something else that was near what you were trying to catch. This doesn't really happen when you're fishing just with a rod and reel off a boat with your family on the weekend. It does happen when you're fishing with these giant kilometers-long nets, or what's called a long line, which can be 100 kilometers long and have 50,000 baited hooks on it. You're not going to catch just swordfish with that. Some commercial fishing methods, notably the shrimp trawl fishing in the Gulf of Mexico, only 5% of the mass of what they catch is shrimp. And these other animals largely, often can't be sold either because there aren't permits for them or because there's no market for them. They're just random fish that you would not ever find at a seafood market. Sometimes the fishermen, if they move fast enough, they can get them over the side and some of them might live, but a lot of them die. A lot of the ones that die are sharks. This was responsible for the deaths of tens of millions of sharks a year. There's also shark finning and shark fin soup. This is often in the news in BC, but there's some misunderstandings surrounding this that I want to get to a little bit. But shark fin soup is a traditional Southeast Asian delicacy associated as it's seen as a show of wealth. The cartilage fin ray elements in the fin are boiled and made into a noodle-like substance. There's no meat in this, and they have absolutely no flavor. They have absolutely no nutrient value. It's a texture thing, and it's seen as a demonstration of wealth. This is often served at business dinners when you're trying to seal an important new business deal. It's often served at weddings and things like this. So to get this, the way that this used to be done is called shark finning. Here we have a hammerhead shark with its fin removed being dumped over the side of a boat at sea where it will slowly bleed to death or drown. Because the fins are valuable and no one eats hammerhead shark meat. So this has become largely illegal, the shark finning, but the alternative to that is landing the whole shark and making sure to only land sharks whose populations can support a fishery to some extent. So there are still places where you can buy shark fin soup throughout the developed world. Largely, it comes from well-managed, sustainable fisheries. This is actually what a lot of my postdoc research at Simon Fraser is going to be focused on. Right now, the United States Congress is considering a bill to ban the sale of all shark fin soup within the U.S., regardless of whether it came from a well-managed fishery or not. I do not support that. Canada in the past has toyed with a bill that would ban imports of shark fins from other places where fisheries are not well-managed. I have no problem with that. But the banning all shark fins, regardless of whether or not it came from a well-managed fishery, hurts fishermen that have been following the rules and are doing nothing wrong. I can rant about that all day. I do on Twitter some days. Some of you have seen. But so an important point with this is a lot of people see this as this is a problem of those weird other people on the other side of the world. This is not something we need to think about. But the U.S. and Canada are both top 20 shark fishing nations. And shark meat is also a major source of shark mortality issues. So when I see activists that are very, very concerned about shark fin soup and shark finning, but are not very concerned about being able to buy a shark steak at the grocery store, it makes me wonder why they're focusing on an issue exclusive to Asia and not an issue exclusive to the US and Europe. But again, could rant about this all day, but I'll move on for now. Do I need to update this? Yeah, I have a slightly older version of this presentation behind me here. Sorry, and in the move, I haven't found my external hard drive yet. So this is a slightly older version. It's now 24% of sharks, skates, rays, and chimeras that are listed as threatened with extinction by the IUCN Red List. The only group in worse shape is amphibians, and they're because of that chytrid fungus disease. The Vancouver Aquarium has a lot of really cool tropical frogs, and they're trying to breed them in captivity to fight this. So the sharks are one of the most threatened groups of vertebrate animals in the world, and no one knows this. We call this the most serious environmental crisis you've never heard of. Some populations of sharks, including some off the east coast of Canada, off Newfoundland, have declined by 90% or more since the 1970s. I usually give this presentation to grade 8, grade 9, grade 10 students. For them, the 1970s seemed like a long time ago. I bet most of the people in this room, or many of the people in this room, remember things that happened in the 1970s, or maybe not if you were really enjoying the 1970s. But it's not that long ago. And these are animals that were swimming in the ocean 100 million years before there were dinosaurs on land. And in my parents' lifetime, we've killed 90% of them. Of some species. Other species are doing relatively well, but this is a significant conservation crisis, and one that people really just don't know anything about. The open ocean species, which are generally the species people are more familiar with, are even worse off. 33% of them are threatened with extinction. So my supervisor at Simon Fraser, Dr. Nick Dalvey, is the co-chair of the IUCN Shark Specialist Group. So he works on this stuff along with other people in his lab, these just global scientific assessments of shark population stuff. It's really interesting and important stuff. If you're ever looking for another speaker on just the mechanics of how these sort of things get discussed, what is threatened versus endangered versus all that stuff, he could be a potentially interesting speaker. But so sharks are in trouble. And I want to, if I've done my job so far, I've convinced you that sharks are neat. Sharks are not something you need to be afraid of. You should value sharks for the ecological role that they play, and we're in danger of losing some. So hopefully your next question is, how can I help? Part one of how you can help, you're doing right now. Learn about this. No one knows about this problem. You guys are all smart people that care about the world around you. No one knows this stuff. And I don't know why that is. But you're learning. I hope you go home and tell a friend or family member something that you learned. And I hope you spread the word. But I want to caution you, as someone who does internet science communication, there's a lot of wrong information about this stuff online, a lot of it from well-intentioned people that are trying to help. So try to find a reputable source of your information, because otherwise then the people that are doing this, like me, need to spend our time not fighting the unsustainable overfishing, but fighting people on our side who are saying wrong things and calling for policy solutions that don't make any sense. So if you follow me on social media, I share a lot of reputable sources that retweeting and or sharing on Facebook from sources that I've evaluated and I trust that are ways for you to get involved. Not consuming shark products is a great thing to do. There are definitely some sort of stealth shark products that you are not really aware that it's shark. If you've ever been to the UK and you've had crappy fish and chips, that's dogfish. They call it rock salmon. There's no such thing as a rock salmon. That's a dogfish. If you've ever had crappy fried scallops, that's skate wing. How many of you follow some sort of sustainable seafood guide, like Seafood Watch or Ocean Wise from the Vancouver Aquarium or something like that? These are, if not these, I recommend that you check that out for sustainable seafood products in general. But they also have some great advice on how to find a fishery that's good. There are shark fisheries that are reasonably well managed. They recommend some of those. But they also tell you, perhaps the most important thing that those places tell you is, under no circumstances eat this if you care about the state of the world. I am surprised at as a new Canadian, I'm shocked at some of the seafood labeling laws here compared to the U.S. because in many ways, Canada is very progressive in environmental legislation compared to the U.S. But in my grocery store in Florida, in my neighborhood grocery store, if I went to go buy a snapper fillet at the seafood counter, it would say what kind of snapper it was. It would say where it was caught. It would say what type of fishing gear was used to catch it. And I went to my Nestor's market in my neighborhood here in Gastown, and it just says snapper. So you can't make an informed choice if that's all it says. So ask at the seafood restaurant, where was this caught? Does this meet Oceanwise standards? I've seen a lot of restaurants in Vancouver have that Oceanwise logo, which is great. But that's probably the single most important thing you can do. You can also help do your part to make sharks more valuable alive than dead by visiting an aquarium or going scuba diving instead of just going to the beach or things like that. And you can express your support for sharks and shark conservation by writing to your elected representatives, writing to policymakers and things like that. DFO has calls for public comments all the time, and things of that nature. And you can also donate time or money to a scientific research lab or a reputable nonprofit. And again, I share a bunch of those on my social media. And I want to close with my favorite environmental quote here. This was by Senegalese conservationist Baba Dayoum. He was talking about gorillas, but I think it applies to sharks really well. And that's, in the end, we will conserve only what we love, we will love only what we understand, and we will understand only what we're taught. Hopefully, I have taught you a little bit about sharks today, and maybe you will love them a little more like I do and want to help conserve them. And depending on how much time I've got left, I'm happy to take any questions.